So this video will cover the first half of chemical bonding, topic 5, looking specifically at ionic and molecular bonds. So we'll start off talking about what a chemical bond is. And all a chemical bond is an attraction between atoms that allows us to have compounds that are made up of more than one type of element. So if we kind of look closer at this diagram, we have elements here on the side. Okay, when we have two or more elements bonding together, so the atoms of those elements are attracted to each other, we get compounds that are over here. So a chemical bond exists in compounds. So for our purposes, in grade 9 we have two types of chemical bonds that we're going to learn about. The first one is an ionic bond, and the second one is a molecular bond. So I'm going to start with ionic bonding. An ionic bonding is the type of chemical bond that happens between a metal and a non-metal. Okay, so metal and non-metal. So that means from something from this side of the periodic table and something from this side of the periodic table. Okay, so when metals and non-metals come together, what happens is we have a transfer of electrons. So ionic bonding occurs when one atom transfers an electron, or maybe multiple electrons, to another atom. We have a transfer of electrons, then we have a positive ion and a negative ion, and those positive and negative ions are attracted to each other, and that's what gives us our chemical bond. On to molecular bonding, which happens when we have a bond forming between two nonmetals. So it's a nonmetal and a nonmetal, which means that they are both from this side of the periodic table. Okay, the right side of the staircase. Or hydrogen over here. So when we have two nonmetals bonding, the atoms interact in a different way, and we see actually sharing of electrons instead. So in a sharing of electrons, it's different than the outright transfer that happens with ionic bonding. Instead, the atoms in this case will be close to each other, of course, because they're bonded, and the electrons in them will be shared between the two nuclei. Okay, so sharing of electrons is going to be what makes a molecular bond. Now, ionic bonds are stronger than molecular bonds, and as a result of that, it usually means that ionic compounds, so compounds that are made from an ionic bond, they are usually solids at room temperature, and molecular bonds or molecular compounds are usually going to be liquids or gases at room temperature. So we're going to move on to the naming part of this. And before we kind of get into the specifics, I'm just going to talk a little bit about this organization called the International Union of Pure and Applied Chemistry, IUPAC, and they are the international organization that sets all the rules that we are going to now have to follow. They do that so that really looking at chemical reactions and doing chemistry, it's a universal language. It's not something that is determined by what language you speak, what country you're from, and all of those rules to ensure that that stays that way are put forth by IUPAC. So IUPAC rules are the ones that we'll be following and the ones that we'll be learning for these naming exercises. So something that you guys need to kind of be clear on is that we have chemical names and chemical formulas. And what we will be doing is going back and forth between them. So I will give an example. So a chemical name, actually I'll start with the formula. So H2O is a chemical formula that we're all very familiar with, and we know it as water, but water is a common name. It is not actually the IUPAC name for this molecule. The IUPAC name for this water molecule, is dihydrogen monoxide. And we'll get to why it's called that in a few minutes. But the point is that from the name, you can find the formula. From the formula, you can find the name. You should be able to go back and forth. Both are important and both are used in different scenarios. But that's what they are. And just to make sure everyone's on the same page, let's talk about a chemical formula for a sec. So when we see the combination of letters and numbers here, the big letters symbolize the element, And then the numbers afterwards mean how many atoms of that element are in the compound. So in this one, we have 2 atoms of hydrogen in this molecule and 1 atom of oxygen, even though there is not a 1 here. Whenever we don't have a number there, we assume that it is 1. That's the general rule. And that means that there's 1 atom of oxygen. So every atom of water has 1 oxygen atom and 2 hydrogen atoms attached to it. It looks kind of like that.